Okay, in this video we're going to talk about the limit definition of a derivative, or basically how a derivative is defined or how we derive or come up with derivatives. To start, we're going to assume we have some curve, a graph of a function f of x. And we have some arbitrary point on that graph. Its x coordinate is some value for x, and its y-coordinate is whatever the value of the function is at x. So we have the point x comma f of x at x. Okay, so these are all things that we've worked with in algebra, algebra 2, pre-calculus. We're talking about a function, we're talking about a point, the graph of a function, a point on that function at a particular value of x. Then we're going to move along the curve and put another point down somewhere along the curve, only this time in the past we might call these x sub 1 and x sub 2, but instead of doing that this time we're going to look at it this way. We're going to move over from x some distance that we're just going to call delta x, or change in x, so that our new point is not x sub 2, but we're going to call it x, the original x, plus whatever change in x we moved along to the right. And so we call that x plus delta x, which is the new x value. So the coordinates of that point along the curve are going to be x plus delta x, that's the x coordinate, and the y coordinate is just going to be the value of the function at that point, or for that x coordinate. So it's going to be f of x plus delta x. So we can now see that we have 2 points, x comma f of x on the left, and on the right we have x plus delta x comma f of x plus delta x. And the distance in between the two x coordinates would be the second x value, which is x plus delta x, minus the first x value, which is just x. And if you were to simplify that, you'd see that the x's will zero out, and we'll end up with that whole quantity equaling delta x. Okay, so this is the setup for what we're going to do next with this. And what I'm going to do, the next thing that I'm going to do is to connect those 2 points with a straight line. And what we do know about straight lines is that straight lines have slopes, and we can calculate the slope of a straight line as long as we have 2 points, which we do have. And this line that we've drawn connecting the 2 points, we're going to call that a secant line. And this is a reference back to geometry, where a secant line is a line that connects 2 points on the circumference of a circle. So you want to look back and remember what we do know about secants from geometry. Oh, we're going to use it slightly differently here, but it's the same idea. We're not working with circles, but we're working with a graph, and we're looking at a line that is going to connect with that graph at 2 points on the curve. And now we can talk about the slope of that secant line. Well, the slope of that secant line is our y2, which is f of x plus delta x, minus y1, which was f of x, and that's all divided by the change in x, which is delta x. And once again, that is the slope of the secant line. We're also going to call that the average rate of change of the function between the 2 points x and x plus delta x. Now if I was to slowly shrink delta x, so that delta x is bringing x and x plus delta x, those 2 points, closer and closer to each other, I would have a point that is moving closer and closer to the original x value. And at every point along its journey, I could find the slope of the secant line that that new point makes with the original point. Well, eventually we're going to get so close that there are no longer 2 points, but we have a line passing through one point, which we call a tangent line, also relating back to something we learned in geometry. We'll continue this on the next video.